Hey guys, back again. Let's go ahead and try to figure out the next step of rotations, and that's going to be combining it all together and rotating not only just about x and y axis, but then other lines. So today we're going to start this problem off with a calculator problem. Um, One big hint that I have for you is whenever that you rotate about a line and it's not an axis, you always have to add or subtract some equations. So your radii are going to have an addition or a subtraction in it, and you'll see that in just a little bit, but I just want that to be like a highlight of this. Whenever you rotate about a line and not an x or y axis, you're always going to have an addition or subtraction onto each of your radii. So we'll go ahead and figure that out here in just a second. So how do you figure out each problem? First thing you need to do is figure out if what we're talking about is going to be a disk or a washer. And in order to figure that out, you need to graph it. So since this is a calculator problem, hopefully you recognize that this equation is a circle with a radius of 5. I was pausing for you guys to say it there. But anyways, so here is our half a circle. Y equals 3 is a line that's up there, and then we're rotating about the line y equals 1. So I'll try to color code this because I don't like that it's all black here. Alright, so we have our half circle in red now. We have our line y equals 3. That is the area. That's the two equations that trap the area. So our area is actually, let's see here, what I can do in green, is this region right here. And we're rotating it about the line y equals 1. So if I were to rotate that region, we would have a disk or a washer method. That's step 1. And hopefully you can see that all this region in here is a gap. It's going to be a hole. There's not going to have, you're going to have this region that's not filled in. So it's definitely going to be a washer method. Okay, second thing. We need to find the equation for each radius. And this is actually the whole big part of it. This is the most important part of this problem. We need to go ahead and set up our integral. And it's going to start off volume equals. This is a washer method. So we're going to have a big radius squared, terrible R, a big radius squared minus a little radius squared. So our big radius, it always goes from the axis of rotation to the curve. So in this case, we're starting at 1 and we're going all the way to the farthest point of the area region. Okay, that's the farthest point on the curve. So that distance, well, you could think of it as top minus bottom again. Top minus bottom is just huge. Top minus bottom in this case would be our root 25 minus x squared. That's our red curve, the half a circle. And we're going to subtract top minus bottom. We're going to subtract 1. And it kind of makes sense. Didn't we reduce the y value that would normally be the whole thing by 1 when I made it go up 1 to y equals 1? So hopefully that made sense there. So we're going to do top minus bottom, the square root of 25 minus x squared. Feel free to stop the video and ask clarifying questions and see if anybody else in the class could help, or if you can get that question answered, or just replay the part if you don't understand something. So top minus bottom, that is the big radius. So you can see how what I was saying earlier, when you rotate about a line for your radii, you're always going to add or subtract a number. So there's your first glimpse of that. Minus, and we're going to go ahead and find the small radius. And in this case, the small radius is the distance from the axis of rotation to the beginning of your curve, because you're trying to find the area of the radius for the hole, the missing piece. So that's just actually going to be top minus bottom. So again, 3 minus 1. I'll even write that out. 3 minus 1 squared. I don't like that that's not blue. And you're integrating, obviously all these values are with respect to x. We're still doing with respect to x because this is a horizontal line, and if you look at your radii, they go up and down. Up and down radii are in the form y equals because they're y values. So everything's with respect to x. The last thing you just need to know is what are your limits, and these aren't as easy as they normally would be. This is calculator, but a good practice here would just be setting the two curves equal to each other. They intersect there, which is the equation 3, y equals 3, and the square root of 25 minus x squared. So if you were to solve this problem, first thing you'd probably do is square it. So you get 9 equals 25 minus x squared. And if it were me, I would add over my x squared, subtract my 9, let's see, I think that's 16, and then x would equal, well, since you take the square root of both sides, you need a plus or minus 4. Let's pause for a minute and make sure, do we need the negative 4? And in this case, yes, you're trying to find the two intersection points. So 4 and negative 4 would definitely be you'd want the negative 4. So you're integrating from negative 4 to 4. And that's your setup for this problem. Since this is a calculator, that's all you need to show. And your answer, you can pause now if you want to try to do this on the calculator. If you guys would not like to, then let's get the answer of, I got 197.822, and I believe that's with pi distributed in there. So that should be your final answer rounded to 3 decimal places. Okay, our next problem. Our next one is actually we're going to try this one with no calculator. And if we need to find the volume of the region bounded by y equals x in the x-axis and x equals 3, and it's rotated about the line x equals 3. So obviously the first thing we're going to need to do is graph this. Non-calculator, you guys can probably figure out what y equals x and x equals 3 are. But I'm going to go ahead and bring it over. Y equals x equals 3 are graphed. And you're finding the area bounded by y equals x, the x-axis, and x equals 3. So you're going to have this triangular region here. And it's almost like a perfect triangle. And you're going to be rotating about the line x equals 3. So when we rotate here, step 1, decide if it's a disk or a washer. This one is a disk. There's no empty space anywhere between the axis of rotation and the area. There's no gaps. The axis of rotation, this blue line, touches the area there, the region. But there's no gap there, so when you rotate it around, it actually is going to make some kind of like pyramid cone shape, if you wanted a visual. But disk method is just integration of pi times the integral of your radius squared. There's only one radius in a disk. So here we are. All we need to do now is figure out, step 2, figure out your radii. Radii, or radius, comes from the axis of rotation to the farthest part on the curve. Notice we drew this line horizontally. X values are horizontal, so the equations need to be in the form x equals. So this is when we're going to have to do all with respect to y. And you can memorize that a couple ways. Sometimes people like to memorize, if you rotate around a vertical line, it's always with respect to y. I like to draw my radii, and I've had success with that with other students. Draw your radii. If you're drawing it right and left, it's going to be in the form x equals, so everything's going to be with respect to y. So now I need to figure out that radius. Well, top minus bottom worked earlier, so since we're doing it with respect to y, let's do right minus left. The right curve is the blue line. That's the equation x equals 3. So you can just do 3. That's your right curve. Minus the curve on the left. In this case, it's the diagonal line y equals x. Fortunately for us, that's the same as x equals y. It's already solved for. So you can just throw it into your equation. 3 minus y, quantity squared. To finish this problem, how you would do this without a calculator, unfortunately we have to finish this, is first FOIL 3 minus y squared. I like to write it twice just so I can see it. 9 minus a 3y minus another 3y is going to give you negative 6y plus y squared. We're integrating this. I'm going to hold the phone for a second here. What did I forget? I forgot to do limits. We never set up our limits. So if my equations are in terms of y and I have a dy, my limit should be in terms of y. So the lowest I go is 0. That's kind of obvious. Highest we go. Well, that would be this this intersection point right there. And that's where the x equals 3 and the y equals x curve intersect. So if you were just to set these two equal to each other, just basic substitution, y equals 3, right? They both equal x. Set the other pieces equal to each other. So our top limit is 3. I don't like that. That's not green. So let's finish. We never integrated. We just simplified. So we're going to have 9y minus y squared, I'm going to divide by 2, so I'm going to get a 3, plus y cubed over 3. And we're going to evaluate that from 0 to 3. Again, feel free to pause the video if people want to catch up or ask questions. Don't forget we're going to have a pi out here. I would do that last. Forget about pi until the end. Just have your answer in terms of pi. When we go ahead and plug in 3, we should have 27 minus 9 times 3 is 27, plus 3 cubed is 27 over 3, I believe is 9, in case I'm going crazy. And then I'm going to subtract, plugging in 0, but that's just going to be 0. So multiply this whole thing by pi. It's kind of nice. The 27 is just canceled for us, and our answer is 9 pi, and that is an exact answer. It's a great answer. Feel free to pause if you have any questions or you'd like to go over it one more time. Okay, so our next problem. Find the volume of the region of the solid generated by revolving the region bounded by the graphs of the equations y equals root x and x equals 4 rotated about the line x equals 5. So again, we're rotating about some line that is not an axis. So root x, this is a non-calculator thing. Root x, we all kind of have an idea what that is. X equals 4 and x equals 5 are both vertical lines. So if we go ahead and sketch those real quick. Oops, sorry. We get, move that over, rotating about the dashed line here. We get this region. Now, it says find the area of the region bounded by the equations root x and x equals 4. They should really say, excuse me, y equals 0 or the x-axis here too, because it should have this. And don't worry, they'll say that on a test or on the AP test. It's just a poorly written question. So here, make that a little bit smaller. Okay, I don't know what happened there, but I don't like it. I don't like that either. Alright, so we got this region in here, rotated about the line x equals 5. So here's the dashed line is my axis of rotation. When I rotate that around there, you see how there's a gap between x equals 4 and x equals 5? That means that we're going to be doing a washer method. Always a little bit more painful. So we're going to have a big radius squared minus a little radius squared with a volume out front. So, with a pi out front, sorry. It would equal volume. So, if we rotate this around a vertical line, you're going to have to be doing this with respect to y again. We're going to go from the axis of rotation for the big radius all the way to the curve, the back part of the curve there. That would tell you the area for the whole circle, and then you would subtract the whole, the inner circle. So, again, my line's going left and right. So that means I'm going to have to change my equation into x equals. So x equals y squared, if you were to change that one. So our big radius is y squared. Obviously I need to square that. Minus the little radius. Oh, can we go, I'll go back a step here. That is a common mistake. That is actually just the equation for that root x flipped over into x equals. It's actually not my big radius. What my big radius would be a right minus left situation. I still have this this x equals 5, where we always have to add or subtract that. So you think about right minus left. Right, in this case, for my big radius, is this dashed line 5. So it's going to have a 5. Minus my left, which is the equation that we just wrote, y squared. That's the big radius, and we're going to square that. So minus my little radius. And little radius, again, is the distance from the axis of rotation to the beginning of the curve. It's the area for that hole, that vacant space in the middle. So get that in red there. Right minus left would get you 5 minus 4. And you're going to square that. So I'm going to integrate, put pi there, and everything is with respect to y now. So my limits need to be with respect to y. The lower limit's pretty easy. That's going to start at 0. But how high does this thing go? Well, I need to know the intersection point where x equals 3 and that root x kind of intersect there. So I want the y value. So I'm going to take x equals y squared, and sorry, it was x equals 4, not x equals 3. And I'm going to set them equal to each other. So y squared equals 4. Do this, and you're going to have y equals plus or minus 2. But in this case, that's definitely a positive 2 there. So we'll get our upper limit of 2. To finish this problem, we'll do a little bit of our simplifying here, and by foiling out. So our first one's going to be 25 minus 5y squared, minus another 5y squared, so minus 10y squared, plus y squared, sorry, y to the 4th. If we go ahead and do y squared, negative y squared minus times negative y squared, you get positive y to the 4th. Minus 5 minus 4 is 1, 1 squared is 1. Still got to integrate this. So I've got 25 and negative 1 give me 24. Integrate that, you get 24y. And then I'm going to have minus y cubed. I got to divide by that 3, so 10/3. Plus y to the 5th, and I have to divide by 5. I already took care of that one. So I'm going to evaluate that from 0 to 2. And don't forget we have a pi out front. A lot of people forget the pi. If I plug in 2, first part, that one's not that bad, 48. Then I've got y cubed, so I'm going to plug in 2 and get 8. And then I've had 10 times 10/3, so 80/3. Bad 0 there. Plus 32 over 5. And I'm going to have to multiply by pi. Don't forget, if we were to plug in 0, you get minus 0. So I'm not going to worry about that guy. And if you were to combine all of that, I know this is a non-calculator problem, but if you were crazy enough to do it, 416 pi over 15 would be the exact answer, all simplified. If you have any questions, you guys can go ahead and restart a video. Please ask questions if you have them. Notes are posted online. You can always replay these. I do have a couple other videos posted online as well.